talk to you. My presentation is obviously going to be in English, so I hope that it translates well for you. If I'm speaking too fast or there's anything you don't understand, you know, we're not in school here. You can just shout it out, throw something at me just to get my attention. That's fine. So you can just advance on. I'm going to be talking about I'll talk a little bit about who I am and where I come from and some of the technology related to NoSQL using MongoDB. Some of you may be familiar with MongoDB or NoSQL, but I'll talk about what NoSQL is and why MongoDB is so great. And I'll show you some examples where we've used MongoDB in some applications that our company has built. So go ahead. Okay, so a quick introduction. Brian Oliver. I work for a company called Brisk Mobile. We're actually headquartered in Toronto, in Canada. So I'm here visiting our Brisk Mobile team that works out of the GFL offices here in Mykolaiv. So we have a group of developers that we use here in Mykolaiv to help us with our mobile development. Our company is Brisk Mobile, but we don't focus specifically on mobile, but we consider ourselves to be one of the best at mobile. So we've developed tons of applications for all kinds of different customers across the world, and I'll sort of talk more about that a bit later. So that's a quick introduction. I'll talk more. I'm going to talk about what NoSQL is. A lot of people, when they hear that, although it's getting better now, they don't really know what you mean by NoSQL, so I'll talk about what that means, what the advantages are to these NoSQL implementations. And then talk specifically about how Brisk Mobile used NoSQL and MongoDB for a very popular iPhone application, which for any iPhone users, I'll tell you what the application is. It's actually a little social game, so you're welcome to go and download it and use that as well. So I'll talk about that. Next slide. Yeah. Okay, so a bit about me, which I've already mentioned. Where we're headquartered, we actually have offices in Toronto, Ukraine, Philippines, and the United States, right, Andre?
Yeah.
That's right.
Yeah. True.
So we're actually one of North America's largest full-scale development shops. And by full-scale, I really mean we can do everything. We can do everything from initial product requirements, design, documentation, through to graphical design. We have graphics artists and 3D modelers that work in our company, so we can build a full application for our customers, which is one of the differentiating factors between us and some other shops. We actually have everything. We do our own project management. We have our own in-house quality assurance group, right through to the delivery of the end product that we're building. So we have quite a breadth of skills within our organization, and this has really allowed us to be very successful in this space. You can jump to the next. So we've literally built hundreds of applications for people. Everything from small applications that businesses might be using internally, maybe it's a mobile application for something they're doing inside. We've done web applications. We've built very large-scale web applications. So one of our big clients is, well, the system we built is called NatureShare, and it's a web-based application and social kind of network for nature enthusiasts. It's built on top of sort of the Autobahn guides, which is another. We were the company that delivered Autobahn guides. I don't know if you're familiar with them, but they're like the encyclopedia of nature. So they have hundreds of paper editions that they've been building and writing for many, many years, and we're actually the company that was licensed to build the electronic versions of the Autobahn guides. So those extended into a system called NatureShare. Another piece to our business, which we've been quite successful at, is building our own internal games. So we are largely a services-based organization where we're building applications for other people, but we also build our own games. So we have an internal games development team at Brisk Mobile that focuses on building mobile games. You can jump to the next slide. Okay, so here's a couple of the titles that Brisk Mobile has developed. This one here is one of our most popular. It's had millions of downloads from the App Store. At one time, it was even ahead of Angry Birds in the top game listing on Apple's App Store. So we have a few other games as well. We're also taking our medieval brand a bit further with a new release that we're going to be putting out shortly called Medieval Japan, which is adding multiplayer components to our games. So we anticipate that's going to be very successful for us as well. Okay, so NoSQL. What does it actually mean? So a lot of us, at least people my age, came from an area, a time where relational databases were everything. When I was in school, there was no such thing as NoSQL. It was all relational databases, and it was relational database was the problem solver for all your database problems. So thinking relationally is challenging. We spend years sort of building this idea of relational models in our head. We get very good at it, and then suddenly a technology like NoSQL comes down the pipe, which is non-relational. So that's really the sparking component of NoSQL was that we would decouple the relational model across a NoSQL implementation, which has lots of advantages, and I'm going to talk about why there's this sort of movement to a NoSQL model and what the advantages are. But they're basically document stores that have no relation between documents. Like so, within a MongoDB, you have. I'll talk about this a bit more. We have documents, which is sort of analogous to tables in a relational world. There's no relation between those tables. So they're all sort of key value pair indexed, and it creates a system that is super fast for any kind of data retrieval or appending operations within your environment, and it's extremely scalable. So these are sort of the two pillars that they were trying to make something that was really good at. So I'll sort of talk about that in this next slide. So advantages of NoSQL, high performance, as I mentioned, horizontally scalable. I'll talk about how that has been made available with specifically with MongoDB, highly available. So it's all based on this idea of the CAP theorem. I don't know if you're familiar with this, with the CAP theorem. And this was a theorem that they came up years ago, and the idea is that there's three pillars to database systems. And those are consistency, availability, and partition tolerance. So those are the three pieces that make up not a relational database, but a database system. But the CAP theorem states that you can't ever get all three in a database system. So you can only ever have two of those pillars within a database system. So if you jump to the next slide, this is kind of how it's laid out. So you've got consistency, availability, partition tolerance. So here's your intersections of those three. So here's where you would have all three. No database system lives in this space. They've yet to figure out a way to actually make one live here. I'm sure that's coming down the pipe. So the idea is that you're going to live in one of these spaces. And relational databases typically live in one of these two. More often this space than this one, but this is where your relational model lives. This is where your NoSQL model lives. Okay, so what they sacrificed on the NoSQL side is this idea of consistency. And what consistency means is at any given time when you're reading data out of the system, is it the true data? So is across your entire data set, is it an exact copy of the data in all your data sets? So what MongoDB has done is they've taken consistency to what they call eventual consistency. So this means when you read data, it may not be the true representation of that piece of data, but eventually all your systems will have the correct value for that particular data. So this is a very important piece when you're building applications using NoSQL, is you have to be very aware of this this feature not being available, or you have to be careful when you're building this system that if you're pulling data out of the system that you need to make sure is consistent. There's little tricks and things that you have to play, but this is one of the things you have to think about when you're implementing a NoSQL model. You can jump to the next slide. So MongoDB, the reason we chose Mongo primarily was that it was a JSON-based document store. A lot of the mobile apps that we build now are using JSON to move data between our server and our client. I'm sure you're all familiar with what JSON is. So MongoDB is kind of separated into a couple components. You've got database, you've got collections. So DB is just like DB like you would know it in the relational world. You've got collections, which are actually tables. And you've got documents, which is really a record within a table. and that's it. So there's no linkage, there's no relational model to MongoDB. It's just Mongo is built on a couple of ways to scale it, and setting it up is so easy. I can't even describe how simple it is to set up a horizontally scalable system using replica set configurations within MongoDB. It's so well set up right out of the box that you really don't have to do anything. And for even more extended horizontal scalability, you can start getting into data sharding, which is a little bit more of a complex topic about how scalability works. So I'm just going to stick with replica set. But if you want to learn more, you can learn about the auto sharding mechanisms that are built into MongoDB as well. The nice thing about MongoDB is, so the application I'm going to show you is written with a Java backend. It uses the Java driver for MongoDB. The driver really looks after everything in terms of communicating with the database, and I'll explain when I sort of show you a map of how the stack looks for a particular game we built, and I'll show you how important and the power within the Java driver itself that makes working with the MongoDB so easy. The other thing about NoSQL, which was very interesting to me, is there's no schema. And by no schema, it really means that you have a JSON representation inside your database, and really your database is driven by your application, as opposed to the other way around in a sort of SQL world or relational world. Typically you have a schema that drives your application. So schema has to match your application. If it doesn't, it gets very challenging. It's actually no schema. You want to add fields, you want to remove fields, you just add and you remove them. It's actually amazing how easy it is to manipulate data within your JSON document store. Horizontal scalability, the fact that they've got drivers for all of the latest and greatest languages, you can sort of see a list of them there. There's actually even more than that, but Java's the one we're using, but they have them for most popular languages, which is great. So let's talk a little bit about how we used MongoDB. So you can jump to the next slide. So we built a game called Bout. And if you went into the App Store and searched for Bout, you would find it, and you can put it on your iPhone. It's actually a very entertaining game to play in a social environment. It's a picture-taking game. It was built by a company called Awkward Hug, and in conjunction with a company called College Humor. So I don't know if you're familiar with College Humor, but they're a huge organization in the US that has, they're kind of like Smosh. They have a portal of videos and humorists. They have actors that actually work for College Humor. They're very well connected in the celebrity world, and they're the ones that work with Awkward Hug to help us build Bout. So that's a little bit about the photo taking game. This is a couple of screenshots from the game. It's a difficult game to describe, and when you first describe it, you think, well, that doesn't sound really that fun, but it's actually a very fun game to play. These are screenshots from the App Store. I actually got lucky enough. That's actually my son down there. For some reason, he got into one of the screenshots, so he's somewhat of a celebrity himself. The idea is that you have a bout consists of a bout prompt, so a title like the best part of your day. And then you can submit pictures to these bouts. So it works in a social environment. So let's say, for example, in the bout game, we were all friends. Okay? I would start up a bout, and this is what the screen looks like when you go to start a bout, and you get a random list of these bout prompts. And College Humor and Awkward Hug have spent tons of time building thousands of these prompts. So they're all silly things, something popping, something you should not keep in your pocket. So they're all really kind of amusing little things that might drive someone to take a creative picture. So it's about trying to get people's creativity in taking pictures. So I would select, let's say I selected this prompt here, and then my game starts. You guys will all be notified in the game that that particular bout has started, and then you can submit a picture to it. Each bout you submit 5 pictures to. Once 5 pictures have been submitted, the person who started it, myself, I can go in and I can judge it. So I then can see all the 5 pictures that were submitted, but I don't know who submitted each picture. I have no visibility of that. You pick the winner, and then it goes into sort of an honor roll type of feed. So that's a really simplistic description of the game, but it's very fun, and the people the majority of the users who use this game are very amusing. The pictures are funny. It's well moderated, so it's somewhat family friendly. They have some very famous celebrities that love this game and play it very regularly. And I'll talk a little bit about that too. Uh-oh, there we go. Let's jump to the next slide. Okay, so I'm going to talk a little bit about the server architecture that we built for this bout game. So I mentioned it was an iOS game, an iPhone game, or an iPad game. We actually deployed the entire server stack out to an Amazon Web Services environment. We used the EC2 instances, and we actually have 5 EC2 instances using Ubuntu 12 that are running Tomcat 7. So we've got 5 web instances, and then we've actually got 6 Ubuntu 12 instances running MongoDB. And then we use the ELB, the Elastic Load Balancing Service, again another Amazon service, to handle our HTTP load balancing between the service and the client. So if you jump to the next slide, here's a nice picture of what the MongoDB, or what the Bout server stack looks like. And I've so here you've got your Mongo instances, you've got your web instances, you've got the Elastic Load Balancer, and you've got your clients along the bottom. I pulled out this MongoDB driver as kind of a separate looking component, but it actually lives, a driver lives inside each of your web instances. But I took it out because it really is sort of the single point of communication. So the driver looks after everything. From an application perspective, whether you're reading, writing from the database, it doesn't matter. You talk to the driver the same way. The driver looks after knowing which instance to talk to, whether it's reading, whether it's writing, and the MongoDB daemons themselves that are running on these EC2 instances look after keeping all the databases sync. So let's just dial back a little bit to when we were talking about consistency, because this is where things become challenging and that you have to think about when you're building applications. The typical replica set architecture in MongoDB is similar to your primary and secondary type of systems that you would set up in a relational world. So you would have a primary and a slave, master slave. You've probably heard that type of terminology. Well, it works the same in Mongo, except Mongo looks after everything for you. So there's actually one primary node, and you can have up to a dozen secondary nodes within your replica set configuration. Starting these things up is as simple as opening up the config file, telling it what replica set to connect to, and it syncs all up on its own. This was really powerful for our Bout server stack because when we released the game, I told you that College Humor is very well connected into the celebrity world. So I'll give you a little bit of an insight into some of the things that I had to go through with this particular application that created some stress, but are kind of amusing to talk about now. I got an email from the person we built the game for on a Tuesday morning that said, we're about to get a celebrity tweet go out about Bout. So Bout is all hooked into the social networks through Twitter, through Facebook, and it drives everybody back into the game, and using share cards, it encourages people to get into the App Store and download the game. So I asked her at the time what we should anticipate from this particular celebrity tweet, and she said, well, let's just say it's a very famous celebrity person who's going to push this tweet out. So she didn't want to tell me who it was at the time because they were still trying to arrange how they were going to actually get this celebrity to send this tweet out. Turns out the celebrity was Katy Perry. And Katy Perry has 28 million Twitter followers. So at 1:30 that day, I get the Skype message that the tweet has gone out. At that point, I jumped into the Mongo configuration and I sat within in the primary database, and I was refreshing the user count to just sort of see the kind of traffic that was going to come in. And we were getting 7 to 10 new users a second when this tweet went out, and that lasted for about 3 hours. So we had thousands of new users come into this system. Now fortunately, because we had a bit of preparation, we were able to sort of explode out horizontally our configuration to handle this increase in traffic. And amazingly enough, this system handled this massive spike in traffic really well. The web traffic actually was never that affected. The only DB scenario that we were watching closely was traffic in on the write node transactions, which means there Mongo load balances those calls across all your secondary nodes. So it was amazing. And then the next day they had another celebrity named John Mayer who put something out on his Tumblr account, and the same thing happened. We saw this huge spike in traffic. But the system was able to handle itself, and customer was happy, and the celebrities are happy, so that's really good. Just to talk a little bit about this fact that nothing's relational. That's a bit of a challenge point, especially for people who have historically been in a relational world. You have to decouple all these relationships when you're working in a NoSQL environment. So what that means is if you have relationships between two entities, you literally need to take a copy of those relationships and store them. It's very easy to do that, but that creates challenges in itself for if something updates your main copy, if you need to have those updates persisted across all of the sort of subcopies that you've made, you have to make sure you're doing that within your application. For actually transacting with the database, they have their own query language. We chose to use something called Morphia, which is a lot like, if any of you are familiar with Hibernate. So Hibernate is an ORM that sits over top of any relational database. Morphia is just like Hibernate, and it gives us this ORM capabilities with a MongoDB database. So it translated your JSON documents coming out of the database right into Java objects, so you could work with them within your application. So very powerful, very fast. We've never had an issue with speed that we couldn't alleviate just by... speed was never our problem in terms of data coming out. What we had to be careful with a little bit with MongoDB was making our collections too large. And that wasn't that it took a while for them to come out of the database. The speed issues were transmitting that JSON document store back to the client and having the client have to deserialize that JSON. So you pay attention to the size of your JSON documents, and that was really the only little tweaks we had to make within the application to make this high available game, and it's very successful. There's literally hundreds of thousands of users using Bout now, which is pretty amazing. So I'm quite happy with that. Let's move jump to this next. So just a quick summary: high availability, high scalability. Those are the two reasons why. Well, okay, I'm going to add one to this that I didn't put on here. Ease of setup. To actually start using MongoDB, it is so simple. So I'm using MongoDB more and more for even just small applications now, where again, I'm aware of the lack of consistency, that we have to live in an eventual consistency world. But it's just so easy to set up and so easy to get it working out of the box that it's almost my first choice now when I look at designing the architecture for the back end of applications. Yeah, so go to the App Store, look for Brisk Mobile, you'll learn more about us. I'm happy to ask any questions. I don't know whether we want to do questions now or you can come and see me after. You know, if you're uncomfortable with the English, you can ask Andre over there or Alex, and they can help with the translations. So yeah, thank you for having me, and I hope you found this somewhat informative.
What about data consistency? You said that MongoDB has eventual consistency.
Yeah, okay. Maybe if we can...
So how do you manage to solve this problem?
So there's a couple of tricks you can do with MongoDB when you're actually requesting... well, it's not actually when you're requesting data, it's actually when you're putting data into the database. So there's something called write concerns. So there's a level of write concerns within MongoDB that's configurable on your actual call to the DB. And by a write concern, what you can do is you can tell the DB, I don't want you to return from this write call until, so there's a couple different levels. The base level is once the write hits the primary database, it returns. So that's what it does by default. The next level is you can ask it for, can you just go back to that slide with the Yeah, this one here.
Sure.
So the next one is you can say, I want you to come back when a majority of the replica set members have gotten this update. And then there's a write concern where you can say, you know, I want you to come back once everything's been updated. The challenge with that is that it slows the application down. Obviously, when you hit your primary node and you tell it don't return it until every member in your replica set has been updated, you want to be a little bit cautious, you know, be careful with that because it affects performance in the application. Fortunately for us, the way we got around that, because I sort of came from this crazy relational world where consistency is all there, it was typical for me in an application to do something like I do an insert to a record in one spot of a particular method, and then maybe further down I select that data back out again to do something else with it, which is not great design, but it's pretty common in the relational world to sort of push and pull data out within a single call. So what we had to think about there was maybe instead of pushing and pulling, that we reuse the object that we pushed at the start. So you know, when we first started working with it, and when you're in a small replica set environment, it's actually very fast. Like the syncs are really quick. And it wasn't until we started getting really high usage in the application that we started to expose the consistency or the lack of consistency that you have to manage in the MongoDB environment. So initially in our sort of development environment and even in our early releases of the application, nothing was ever exposed. But then when usage picked up and there were lots of people hitting, you know, we'd sort of see these weird things. Just the about people would send me these screenshots saying, you know, I just started about here and I don't see it over here. And then you start thinking, oh, consistency. So then you dig into your application and you sort of mitigate those challenges by either tinkering around with write concerns or you know, or reusing data in other spots of the application. So those are some of the challenges that we had to work with.